Hello everyone. The next chapter which we are going to start, that is class 10 chapter 5, heat. The topics which we are going to study in this chapter, that is the latent heat, regulation, anomalous behavior of water, dew point and humidity, specific heat capacity. As usual, we are having can you recall section at the start of this chapter. The questions which are asked here, that first question is what is the difference between the heat and the temperature? Second question, what are the different ways of the heat transfer? Regarding with that, all these two questions we have studied about the heat transfer and all in the previous standard. In the previous standard, we learnt about the heat and different types of the heat transfer. We have also performed few experiments related to expansion and contraction of the solids, liquids and the gases. We have learned about the difference between the heat and the temperature. We also have seen how temperature is measured using a thermometer. Concepts like the latent heat of transformation, anomalous behavior of the water, dew point, humidity, specific heat capacity are related to certain phenomena experienced by us in our day-to-day life. Let us learn about these concepts in this chapter. So, as we have studied about the various different heat transfer, conduction, convection, and the radiation in the class 8 regarding with this chapter of the heat. Next, also we have studied about the various different expansion and contraction of the solids, liquids, and the gases in the class 9. Now in this chapter, we are going to study about the phase transformation of the heat. Again, anomalous behavior of the water, dew point, humidity, specific capacity, and many more topics. From that, first topic is the latent heat. Again, we are given here one activity. What is that activity? Try this. Take a piece of the pieces of the ice in a glass beaker as shown in the figure 5.1. We have to take the pieces of the ice in a one beaker, insert the bulb of a thermometer in ice and measure its temperature. We have to insert the thermometer in that and measure the temperature of that solution. Put the beaker on the stand and heat the ice using the burner. We have to take here the Bunsen burner and try to heat that container filled with the ice. Then record the temperature using the thermometer after every minute. As the ice is heated, it starts melting. Stir the mixture of the ice and the water. Continue the heating even if after ice starts melting. Draw a graph of the temperature versus time. So this is the simple activity. We have to take record the temperature of that mixture with the help of this thermometer after the every minute, and we have to plot the graph for that of the temperature versus time, and we have to observe what happens there. You will observe that the temperature of the mixture remains 0 degrees Celsius till the ice melts completely. If we continue heating, even after conversion of all the ice into the water, the temperature of the water starts rising and reaches up to the 100 degrees Celsius. At this temperature, water starts converting into the steam. The temperature of the water remains constant at the 100 degrees Celsius till all the water gets converts into the steam. The graph of the temperature versus time is shown in the figure 5.2. In this graph, line AB represents conversion of the ice into the water at the constant temperature. When ice is heated, it melts at 0 degrees Celsius and converts into the water at this constant temperature. The ice absorbs heat energy during this transition, and the absorption of the energy continues till all the ice converts into the water. The temperature remains constant during this transition. This constant temperature at which the ice converts into the water is called as the melting point of that ice. So, from this experiment, we understood as we have to plot the graph of the temperature versus the time. Here in this figure 5.2, they have plotted the graph of the temperature versus time. Here the temperature scale is marked in the terms of the 10, 10, 20, 30, 40, 50 degrees Celsius up to the 100. And here at the interval of the two scale is marked. As we can see here, the temperature of the water remains the constant from the A to B. As for this part, that is from the A to B, as there is the ice. Till the point B, that is the 4 minute. So we can say here till the 4 minute the ice is the state of that ice is in the ice state only. After that, it starts gets converting into the water. So from that, so here we can see here the graph, uh, which is rising as the linearly. So here it is getting converted into the liquid form, that is the water, till the temperature as the water starts boiling, that is the 100 degrees Celsius. And after that, again we can see here the temperature is going to be the constant. So because as the liquid, that water is gets converted into the gaseous state, that is the steam. So from this, we can see here the concept of the melting point of the ice. So the temperature remains constant during this transition. This this constant temperature at which ice gets converts into the water is called as the melting point of that ice. So, thus, during transition of the solid phase to the liquid, the object absorbs the heat energy, but its temperature does not increase. This heat energy is utilized for weakening the bonds between the atoms or the molecules in the solid and transform it into the liquid phase. The heat energy absorbed at the constant temperature during transformation of the solid into liquid is called as the latent heat of the fusion. So as we have seen here that the amount of the energy, मतलब जो heat जो provide यहाँ पर की जा रही थी इस experiment में, so the heat energy is absorbed by the ice cubes which are present in the container or the beaker. But मतलब वो heat energy गई कहाँ पर? So that heat energy is absorbed by that to break down the bonds between the atoms and the molecules which are there in the state of the solid in the form of the ice cubes. So after the breaking of the bond, so they starts get converting into the state, into the liquid state, and after that again into the gaseous state. So जो heat यहाँ पर जो provide की गई थी, so that heat gets for utilized for the weakening of that bonds, and that heat only we are called it as the latent heat of the fusion. So there are the two types of this latent heat. One is of the latent heat of the fusion, and again one is the latent heat of the vaporization. So basically, the latent heat of the fusion is for conversion of the or the transformation of the solid into the liquid state. So here we are having the definition of the latent heat of the fusion. So क्या है definition? The amount of the heat energy absorbed at the constant temperature by unit mass of a solid to convert it into the liquid phase is called as the specific latent heat of the fusion. This is one definition for the latent heat of the fusion. Again, once all the ice is transformed into the water, the temperature of the water starts rising. It increases up to the 100 degrees Celsius. Line BC in the graph represents rise in the temperature of the water from the 0 degrees Celsius to 100 degrees Celsius. Thereafter, even though the heat energy is supplied to the water, its temperature does not rise. The heat energy is absorbed by the water at this temperature and used to break the bonds between the molecules of the liquid and convert the liquid into the gaseous state. Thus, during transformation from the liquid phase to the gas phase, heat energy is absorbed by the liquid, but its temperature does not change. The constant temperature at which the liquid transforms into the gaseous state is called the boiling point of that liquid. मतलब जो कांस्टेंट टेम्परेचर जहाँ पर जो लिक्विड जो है वो गैसियस स्टेट में कन्वर्ट होना स्टार्ट हो जाएगा, देन दैट पॉइंट इज कॉल्ड एज द बॉइलिंग पॉइंट ऑफ दैट लिक्विड. और द हीट एनर्जी absorbed at the constant temperature during the transformation of the liquid into the gas, it is called as the latent heat of the vaporization. So here we are having the definition of specific latent heat of vaporization, that is the amount of the heat energy absorbed at the constant temperature by unit mass of a liquid to convert it into the gaseous phase is called as the specific latent heat of vaporization. So, as the different substances will have the different specific latent heat of the fusion and the vaporization depending on their melting and the boiling point. So here we are given one chart regarding with that different substances have different melting points and boiling points. These values of the melting point and boiling point and latent heat depend on the atmospheric pressure. So here we can see here the water and ice having the melting point 0, boiling point 100 degrees Celsius. that specific latent heat of the fusion in kilojoule per kg, that is 333 calorie per gram, that is 80 kilojoule per kg to 256, that is a specific latent heat of the vaporization, and 540 calorie per gram. So in the numericals, all the specific latent heat of the fusion and the vaporizations the uh, along with their values are given in the numericals. So next is that next part, that is regulation. So you may have seen the preparation of an ice ball. First, an ice slab is shredded, and then the shredded ice is pressurized around. Then the shredded ice is pressurized around the tip of the stick to prepare the ice ball. How does the shredded ice convert into the solid ice ball? If two small pieces of the ice are taken and press them against each other for a while, they stick to each other. Why does this happen? So the concept which works behind this, that is the regulation. So again we are having one activity here. Take a small slab of the ice, a thin wire, two identical weights. Activity: put a slab of the ice on the stand as shown in the figure 5.3. So we have to take one ice slab attached with the two weights, one string. So we have to put that in the that ice slab on the table, and the wire or the string which connected with the weights as shown in the position, that is in the figure 5.3. Hang two equal weights to the two ends of the metal wire and put the wire on the slab as shown in the figure. What do you observe? It is observed that the wire gradually penetrates the ice slab. After some time, the wire comes out of the lower surface of the ice slab. However, the ice slab does not break. The phenomenon in which the ice converts to the liquid due to the applied pressure and then reconverts to the ice once the pressure is removed is called as a regulation. मतलब यहाँ पर जो हमने मेटल के वायर और जो यहाँ पर दो वेट्स वहां पर अटैच किए थे, एंड वी हैव पुट दैट मेटेलिक वायर इन द आइस. सो मतलब जैसे जैसे वो उस पर प्रेशर पड़ते जाएगा वो आइस क्यूब पे, सो दैट वायर विल बी गोइंग डाउनवर्ड्स एज वी हैव अटैच द वेट्स एट बोथ द एंड्स ऑफ दिस मेटेलिक वायर. सो मतलब वहां पर जो वायर है वो आइस से पूरे पास हो जाने के बाद भी दैट आइस स्लैब इज इन द कंप्लीट, सो इट डज नॉट गेट्स ब्रेक डाउन इनटू द टू डिफरेंट आइस क्यूब्स. So this is the property, that the phenomena in which the ice converts to the liquid due to the applied pressure and then reconverts to the ice once the pressure is removed, then this property is only called as a regulation. So the melting point of the ice becomes lower than the 0 degree Celsius due to the pressure. This means that at the 0 degree Celsius, ice gets converted into the water. As soon as the pressure is removed, melting point is restored to 0 degree Celsius and water gets converted into the ice again. So this is only the experiment which demonstrates that the regulation principle. Again, in the above experiment, the wire moves through the ice slab. However, the ice slab does not break. Why? Is there any relationship of the latent heat with the regulation? You know that as we go higher than the sea level, the boiling point of the water decreases. What will be effect on the melting point of that solid? So this is all the anomalous behavior of the water, which we will be studying in the next part. Again, one can you tell question is there. We feel that some objects are cold and some are hot. Is this feeling related in some way to our body temperature? So again, this is of the anomalous behavior of the water, which we will be seeing in the next part.